Okay, we're going to finish up section 5.3. So this is, whoops, guess I got my thing backwards here. So this is going to be section 5.3, part 2. We just got a couple more expressions we need to wrap up here. They give us, for example 4 in the book, they want us to figure out for part A, what's the integral of 0 up to pi of sine of x dx. And then for part B, what's the integral from 0 up to 2 pi of sine of x dx. And if you remember, the definite integral tells us the signed area. So if we kind of look at sine's graph, we know sine's graph looks like this. So when we go from 0 up to pi, that's going to add a bunch of positive area. So we expect this to be some positive number. When we go up to 2 pi, that's going to add the similar amount of negative signed area. So we expect when we do the full integral from 0 up to 2 pi, we expect the area is going to cancel out. And we expect for part B, we're probably going to get 0. Whereas for part A, when you only go up to sine, you only go up to pi, we're going to expect to be some positive value. So for part A, we want integral of 0 up to pi of sine of x dx. I need to think who has derivative sign, and that's going to be negative cosine of x. I evaluate it from 0 up to pi. So this is going to be negative cosine of pi minus negative cosine of 0. So it's the negative cosine of x evaluated at the upper limit minus negative cosine of x evaluated at the lower limit. That's from Fundamental Theorem of Calculus Part 1. Cosine of pi is negative 1, so we get negative 1. Minus a negative is plus. Cosine of 0 is 1. Minus a negative is positive, so we get 1 plus 1 is 2. So it looks like the area under this first part of the curve here from 0 up to pi, that area is 2. So then part B wants us to do the same thing, but they want us to run out to 2 pi instead of just pi. So for part B, we say, all right, what's the integral from 0 up to 2 pi of sine of x dx? So it'll be negative cosine of x is still the antiderivative of sine of x. We evaluate it from 0 up to 2 pi. So this will equal negative cosine of 2 pi minus negative cosine of 0. So cosine of 2 pi is 1. So this will be negative 1 minus a negative is positive. Cosine of 0 is 1. Negative 1 plus 1 is 0. And this is what we said we expected to have happen, because that positive area, when you go out to 2 pi, you add all this negative area to it. And due to the shape of sine, the positive area and the negative area will cancel out. So you end up with 0 for that one. So for the next one of these integrals they want us to look at is going to be example 5. So this is going to be one of these with the exponential function. They give us what's the integral from negative 0.3 up to positive 0.6 of e to the 3x minus 1 dx. So they want us to calculate that integral. So I need to figure out what's the antiderivative of e to the 3x minus 1. Well, e is its own derivative. If I had e to the 3x minus 1 and I took the derivative of it, the chain rule would apply. The e part would stay the same. I'd leave the 3x minus 1 alone. Then I would multiply by the inner derivative, which would create a 3 that would be out here. So I need to put a 1/3 out front that's going to cancel out the 3 that's created when I take the derivative. It'll cancel out the 3 from the chain rule. So I evaluate this from negative 0.3 up to positive 0.6. So I get 1/3 e to the 3 times 0.6 minus 1 minus 1/3 e to the 3 times negative 0.3 minus 1 And we'll just total that up and see what that ends up being. So 1/3 e to the power of 3 times 0.6 minus 1. All that minus 1/3 e to the power of 3 times negative 0.3 minus 1. And this ends up giving me about equal to 0.692, more or less. Okay. So right before the final example, we have one last equation we want to get. We have the integral of a up to b of 1 over x dx, which you can also write as the integral of a up to b of dx over x, is equal to natural log of absolute value of b minus natural log of absolute value of a, which equals natural log of b over a. So we are going to use this to solve the last bit here, and then that's going to do it for section 5.3. This section 5.3 is kind of a shorter section. So for example 6, we got two things we're trying to do. Part A, we want what's the integral from 2 up to 8 of 1 over x dx, and part B, we want what's the integral from -4 up to -2 of dx over x. So if we want the integral of 2 up to 8 of 1 over x dx, by our formula up here, that's going to equal all the way down here to just natural log of the upper limit over the lower limit. So this will be natural log of the upper limit 8 divided by the lower limit 2, which is just natural log of 4. So that's using that formula up there to get part A. For part B, dx over x is a similar form, and it also is equal to natural log of the upper limit, which in this case is -2, over the lower limit -4, which negative over negative is positive, and 2 over 4 reduces down to 1/2. And that is going to wrap it up. So that does it for section 5.3, and we'll stop there.